Alright, welcome to the second half of 4.2, which I think in the guided notes is called, and in Hawk's homework is called 4.2b, so I'm going to tack that little b on there at the end. This is the word problems, basically. Now, in this section we did linear and quadratic functions. We've already done word problems with linear equations back in the last chapter, so the 4.2b is just about word problems with the quadratics. Now with a quadratic, because it's a parabola and there's that vertex, so it's either a bowl or a hill. So that vertex is either a maximum value or a minimum value. And so the word problems here are going to focus on what we call maximizing or minimizing. So in the guided notes they kind of talk about, examples. Profit would be one. So as you make a product, it costs maybe a lot to make, and you're not getting too much money back, so your profit margin is pretty small. But as you make enough, you can scale the production in such a way that it's cheaper to make a whole bunch of them, and then you're getting a whole bunch of revenue, so your profit margin is large. And then after some point, it still costs a whole bunch to make. It's costing more and more to make them, and since the price isn't changing, your profit margins go back, smaller again. So you can imagine that there's this, hump where it costs a lot and you're not getting a lot of profit, and it costs a little bit less, you're getting more profit, so you have a whole bunch of profit, and then again it costs a whole bunch and you're not getting a lot of profit. So that vertex, that top of that hill, would be how to maximize your profits. Parabolas are also the shape of a rocket launch. So rockets travel in a parabolic arch because the gravity acceleration gives you g squared, I think. Yeah. Oh no, acceleration squared, right? So, which is g. So anyway, they follow a parabola as well. So if you maximize that, that would be the peak of the rocket's travel, like how high it goes. You could minimize some stuff, like back to production. You could minimize how much it costs to make a product, that sort of thing. All right, so they talk about it in the guided notes. I'm going to talk about it briefly and then get into some problems. So for a problem that can be modeled by a parabola, we can minimize or maximize the function by finding the vertex. So with, I was showing you guys, if it's a parabola that's opens up, it's a little bowl, and that bottom of that bowl is the vertex, that's going to be a minimum. Or it's one that opens down, so it looks like a hill, and that vertex is going to be a maximum. Okay, so at the end of 4.2a, I actually didn't talk about this because I just focused on the completing the square. But there's actually a vertex formula. So it's written here. For f of x equals ax squared plus bx plus c, the vertex is given by this thing. So this thing says negative b over 2a, comma, f of negative b over 2a. So below this I've written h and k. Remember, the vertex is hk. H was the x value, k was the y value. This is you plugging the x value into your function, and we know that that's how we get y's. In goes x to our f machine, out comes a y from our f machine. Okay, the thing that's nice about this is this has the completing the square but all wrapped up in it. Here is the 1/2 b. This division by a is making sure that I have a leading coefficient of 1, and then you plug that value in to find the k or y value. Okay, so on an exam, obviously I don't actually care how you find the vertex. If you never want to complete the square, you can always do this, that's fine. One reason you might not want to, again, it's up to you. One reason you might not want to is by completing the square, it kind of makes solving for the x-intercepts easier because you can use that perfect square technique. But even if you don't have it in perfect square, you can always solve it by factoring or the quadratic formula. So it doesn't actually matter. Oh, excuse me. So there are a couple problem types. Let's look at the first one that I call the garden problem. So the back of Tom's property contains a creek. he's going to enclose a rectangular area to use as a garden, and he's going to use the creek as one side of the rectangle. If he has 460 feet of fencing, what dimensions give him the maximum area, and what is the maximum area? So basically, he's only going to use fence on 3 sides of his rectangle, and the other 4th side is going to be the creek itself. Here's my black pen. Okay. So here's my picture. I guess the water would flow this way, right? So there's my creek and the waves of my creek. And this is going to be his fence for his garden. Pretty. Okay. So he has 3 sides, and all together he's got 460 feet of fencing. So I'm going to label these as L and W. It doesn't matter which ones you make L and which ones you make W. All that matters is that you're consistent, right? Okay, so you can kind of imagine, just think about this on like a sliding scale. I could have a really skinny garden, and that would make it really, really long if I'm going to use all of my fencing. Or I could make it really wide so it would go out really far this way, and then it would be a really narrow garden. And as I do that, the area of the rectangle is going to change, and we're going to show that that area function is a parabola, which means we can use minimizing and maximizing on it, so we can find the vertex. So the things that we know: he has 460 feet of fencing. So the first thing would be that W plus L plus W is 460, right? Because all of the fence he has to add up to 460, which of course 2 W's plus L is 460. All right, the other thing we know is we're looking for area. That's one thing we want to know. What is the maximum area? Okay, so for area, that gives us a way to relate length and width. So the area is length times width. So we can use these 2 equations and do a substitution and get a function of just one variable. All right, so let's flip the page and do that. Okay, so we can combine equations 1 and 2 via substitution and get a function of one variable. That's what we did back in 8.1, right? We did a substitution, and then we just had an equation of one variable, and then we could solve. So the difference here is that it's a function, not an equation. So instead of writing y, we're going to write a of whatever variable. Okay, so equation 1 was 2w plus L is 460. And equation 2 says A was L times W. So it doesn't actually matter which variable you solve for in the first one, but since we want a function of area, obviously we're going to be plugging into 2. So for equation 1, let's solve for L. So solve equation 1 for L. we get that L is 460 minus 2W, and now sub into equation 2. So 2 says A is L times W. We just found that L is 460 minus 2W times W, which when you distribute, you have 460 minus, 460W minus 2W squared is A. So this is a function, right? If I write it with function notation, I get this. And let's go ahead and write it in decreasing power order. All right. I told you guys that functions are machine. It's in goes one thing, out comes another. So on this one, let's think about that. This thing is saying area of W. W here represented our width. So in this function, in goes width, out comes areas. So this machine takes in widths of my garden and gives me the corresponding area that I would have. Because encoded in here is a relationship of L. So you need L in order to find area, but I already did that. I took care of that. I wrote L in terms of W, so I only have W. So I only need to know the width to find the area now. Okay, so if you look at this, this is a W squared, which means it's a parabola, and it's got a -2. So this is a parabola that opens down. So this opens down, which is good because we were asked to maximize, right? So if we're going to maximize, that vertex had better be a maximum, because if it opened up and we were asked to maximize, this parabola goes up to infinity, so there is no maximum, right? All right, so this opens down. The vertex is a maximum. Okay, the vertex is a maximum. So vertex is given by -b over 2a, comma, f of -b over 2a, or a, you know, whatever our function is. So find so they wanted to know what is the maximum area. So do you need the h or the k value? The h is in, the k is out. Because you need to know the area, you have to find both the h and the k value. So let's find h. It's -b over 2a, which is -460 over 2 times -2. So I have this negative, gives me something positive. That's good, because remember, this is supposed to be a width. This h value is supposed to be a width. I don't want a negative width. Okay, so this is 460 over 4, which is 115 feet. So the maximum area occurs when the garden is 115 feet wide. Okay, then the k value is an area. That's an area, and that's given by my function. So find your width, area at 115 feet. So that's -2 times 115 squared plus 460 times 115. So if you plug this into a calculator, which of course you guys are going to be able to do, you get 26450 square feet, right? So in out, I needed to know area, so I had to find both the h and the k value. So the other thing that they ask is the dimensions of the garden. Since you know the width, you can find the length, because the length, remember, is 460 minus 2w. So you have your picture, and 115 goes to each width. So the only thing left is this L. Okay. Okay, so 460 minus 2 times 115 is 230. Which, right, of course, that makes sense. All right, so word problem, word answer. You guys aren't going to be able to give a word answer on the Hawks exam, but I still like that we practice that. So the maximum area is 26,450 square feet with dimensions (115 feet by 230 feet. Done. Now when I was doing this and I found the length, I said, oh yes, of course, that makes sense. Every single time you do these problems for maximizing a area, a rectangular area, it's always the exact same. Every time. If you had all 4 sides, the way to maximize the area is with a square, so that all sides were equal. If you have just 3 sides, then 2 of the sides are one length, and then the last side is double those other 2, right? Because you could imagine if you cut this L in half and stuck it over there, you'd be back to a square. So then if you only had 2 sides, then again you would want them to be equal. So as soon as I know the width, I automatically know the length. And the reason that happens is this formula. 2 width. So of course the length has to be double whatever was remaining. All of the garden problems work exactly like this. You have one equation that tells you how to sum them up, and then you have your area, and then you substitute, and it's a parabola that opens down, and you find your vertex. Done. The only thing that you have to kind of look out for is, what do you need to know? Do you need the h or the k of your vertex? So do you need to know the dimension, or do you need to know the actual area? And that's why I like to write this in out to kind of help remind ourselves.